In this dataset, I have data from an experiment to measure the quality of computer components, and in the experiment they varied the speed and the angle that was used for the machine making the components, and then there's a quality measure. And if I first of all look at a graph with response variable quality on the vertical axis and one of the predictors, let's say speed, on the horizontal axis, then we can see that there's a slight positive association between quality and speed, and we can quantify that with a simple linear regression model with quality as the response, speed as the predictor, and we can see that there's a significant linear association between quality and speed because we've got a p-value there of 0.031 for the speed variable. And if we look at the regression equation, we can see that there's a positive number multiplying speed. So that tells us it's a positive linear association between quality and speed. And so we might think, for example, that if we wanted to increase the quality of the computer components, that what we need to do is increase the speed at which the machine is running. But hold on, there's another variable that is at play here, the angle at which the machine is set. And now, if I add that to my picture, we get a very different story. So again, I'll put quality on the vertical, speed on the horizontal, but this time I'll add angle to the graph by coloring the points differently according to the angle at which the machine is set. And now we can see, for example, if we fix the angle at 1, we have the blue circles, and now we have a negative association between quality and speed, just focusing on these 3 points at which the angle was set at 1. If the angle is set at 2, we've got these red squares, and again, we've got a negative association between quality and speed. It's the same story no matter what we fix the angle to be. Let's go up here to the angle at 6 with these yellow triangles. And again, the association between quality and speed is negative. And so if we quantify this using a multiple linear regression model this time with 2 predictors, so we'll do that by adding angle as another predictor. And let's look at the results. So in the coefficients table, I want to look at these 2 rows. The 2 p-values, they're both significant, 0.000. So both of the predictors are significant in this model. But now, if we look at the regression equation, we've got a negative value in front of speed. And that's what we saw in the graph, that as speed increases for a fixed angle, the quality goes down. And then this coefficient here is positive. That means for fixed speed, if we increase the angle, then the quality will go up. So what we want to do here to get the highest quality is to have the angle high, okay, but at the same time decrease the speed, and that will increase the quality. So very different story. This is an illustration of something called Simpson's paradox, where the association between 2 variables can be in one direction and it gets reversed when we account for another variable